physics curriculum at Krea University has been designed, we don't have separate lab courses in physics. Every theory course also has an inbuilt lab component. So what this does is it allows students to learn the theory in the classroom and then have hands-on experimental experience of those same concepts in the lab as part of the same course. So for example, many of the students, they come to the lab to do experiments at whatever time it suits them. So we don't have very specific and rigid lab hours. It's an open lab concept. So whenever a student has a free slot, they are welcome to come and work on the experiments, as long as they finish it, of course, within the time frame of the course itself. Now, what this does is, it allows students not just to have hands-on experience, but because it's an open lab concept, because they are free to come whenever they want, it gives them a certain amount of flexibility. In addition, it's not like a spoon-feeding system where the students are told to follow a certain procedure. They are given the instrument, they are given the manual, and they explore it themselves. So it also encourages independent investigation of whatever phenomenon they are trying to study. A lot of the courses have inbuilt experimental components apart from the lab, like individual projects that students can undertake. And in the past, students have done experiments relating to electronics, relating to mechanics, optics, even quantum mechanics. They have designed their own experiments over here.
In our undergrad program, the fourth year has a component called capstone project, which has option to be theoretical and practical both. So some students have done quite a rigorous practical project using the equipments in our physics lab. One of the students, she has done properties of nanoparticles earlier. Right now, two students are exploring the Raman modes using lasers of two different frequencies. We also have a physics fiesta, an exhibition which runs for 2 days, and in that we show a quite extensive range of experiments which students, more like all of the experiments are designed by students, where we show basically physics in a more popularized version. So it is very like we show magnetic levitation, we show non-Newtonian fluids, this kind of experiments which is basically open to all.
So this is the telescope. This is the pride of the physics lab. It's a Dobsonian reflector telescope. It has a length of more than 1 meter and an 8-inch aperture diameter. We often take this up to the terrace with the students and we conduct night sky viewing events. So we've looked at the moon and the craters in great detail. We can see Jupiter with 4 of its moons even, and we can see Saturn with its rings. And apart from that, of course, we can also see more distant objects like some nebulae and the Andromeda galaxy. Next year onwards, we are also starting to offer a special astronomy track in physics. And when that happens, this telescope, which for now is only used as a means to popularize science, it will also become a part of the curriculum, and students will be handling this on a regular basis.
So we have quite unique branch of equipments and facilities here. One of them is this telescope which you just saw, and we also have an optical table, a 3D printer, and few are also in the line in future which are coming. We also have a prototype of NMR experiments, and this is quite unique at undergrad level.
So this is the E/m experiment, where we're essentially calculating the electron charge, the mass ratio. What happens is that there is a vacuum chamber in which the electrons are accelerated using a potential difference from the cathode and the anode, and then it is passed through Helmholtz coil, which basically creates a uniform magnetic field which rotates the trajectory of the electron. So now it moves in a circular trajectory, and we can change the diameter of the circle by increasing the current and decreasing the current. So through the measurement of the diameter of the circle, we end up calculating the E/m ratio. This glass bulb is filled with argon gas, and when we're exciting the electrons, it's getting accelerated. So when it makes collision with the argon atoms get excited, which is why we're seeing a green color or the green circle inside the bulb.